So this is just some review from really the last 3 classes on ionic naming. Remember, whenever you name something ionically, the first element is always a metal, which is our cation. Cations are things with a positive charge. And what you have to be careful with is you have to make sure that that metal isn't a transition metal. Because if it is a transition metals can form more than one possible positive charge. So if it's a transition metal, you have to use parentheses to clarify what kind of charge that metal has. And then the second part of the name, the second element is going to be your nonmetal, your anion. Anions always have negative charges. And that's when you're going to change the ending to "ide." So if it's like, say, sulfur is the second element, it'd be sulfide, or fluoride, chloride, bromide, iodide, oxidide, nitride, and so on. Now, there's also these things called polyatomic ions. So polyatomic ions are ions made of many atoms, okay? Now, if most of these polyatomic ions, the exception of ammonium, are going to be anions, so with those, you don't change the ending to "ide, you just leave it how it already is. So let's try doing these 4. So SN, who thinks they know this one? What would this be? SN2S, how would you say that? Trevor, go ahead.
Strontium sulfide.
So SN is not, SR is strontium. But you're right, if it was SR, it would be strontium sulfide. But that's 10. So with that in mind, how would we do this one? You got it, yeah? Not just tin sulfide, because tin is tin and lead, tin is technically not a transition metal. Tin and lead, those are 2 exceptions. I got them written on the board. I'll have this written on the board for you. Not all the polyatomic ions, but I'll remind you that tin and lead, treat them like transition metals. So tin is going to be a transition metal, so we're going to have to use parentheses because it forms more than one possible charge. Tin something, and then S is sulfur, so you'd say sulfide. So then what would be the charge in parentheses here? No? 1. Good. So how you would know that is you focus on what you do know. You do know that sulfur is always going to be a -2 charge. You know that because sulfur is in group 7 group 6 or 16, and they all form -2 anions. You know that your charges have to balance out to 0. I have 2 tin atoms to cancel out a -2 charge. If each tin atom is a +1 charge, that would cancel out my -2 and get me to 0. So that's why it is tin 1 sulfide. A common mistake I see is that people will see, oh, there's a 2 there, so that means that's what goes in the parentheses. And that's not true. What goes in the parentheses is the charge on each tin atom, not the number of tin atoms. Okay? All right, let's go over here to the second one. Ammonium sulfate. What would be the formula of that? Any thoughts? Go for it now.
NH4 in parentheses 2S.
Now, it wouldn't just be, you will have an S in there, but it's not just S because it's not sulfide, it's sulfate. So that's tricky, right? So you have to memorize these polyatomic ions over here. So sulfate would be SO4, but you are right, like this would be correct because sulfate is a -2 charge, and ammonium is a +1 charge. That's why we need 2 ammoniums. Each ammonium is a +1. Each sulfate's a -2. That's why we needed 2 ammoniums to cancel out the -2 of the sulfate. Okay. All right, the number 3, iron 3 acetate. How would we say that? Well, iron is Fe. Acetate, that's the one that's really complicated, right? It's C2H3O2. Now, iron is a +3 charge. This is a very common mistake I'll see is people, again, they see that Roman numeral 3 and they think, oh, that means we have 3 irons. That's not what that's saying. That Roman numeral 3 is saying that each iron has a +3 charge. You know, or you should memorize that each acetate is a -1 charge. Charge has got to go to 0. So that's why I'm going to need 3 acetate. I need 3 minus 1s to cancel out the plus 3 of the iron. Okay? All right, last one. I almost said the answer. CaNO32, what would that be? Yeah, go for it, Trevor.
Calcium nitrate.
Calcium nitrate, good. Ca is calcium. Now, before you go further, you got to ask yourself, is calcium a transition metal or not? Calcium is not a transition metal. So we don't need parentheses. And then NO3, that's nitrate. The reason, some people are like, well, you know, what do I do with that 2? Do I put the 2 in Roman numerals after the nitrate? You don't. All that 2 is saying is that I need 2 minus 1s to cancel out the plus 2 coming from the calcium. Okay. All right, so that's ionic naming. So now we're going to move forward into covalent naming. And I want you, I don't know if I showed to you in this class. Some classes I've kind of left this up here. This is, at the end of today, this entire slide should make sense to you. And I want to focus on the left-hand portion first. So that after today, from now on, you're going to have to ask yourself, is the first element a metal? If it is, if yes, then it's going to be ionic naming. Where when it's ionic naming, you got to ask, is it a transition metal? If not, then you can just do your normal naming, name the metal, then the non-metal, and add "ide." If it's a transition metal, then you got to do the Roman numeral thing in your parentheses to tell us what the charge is. And then you got to make sure the charge is balanced. Now, if no, that's what we're talking about today. Okay, so I'll go over this. I'm not going to try to explain this from this slide, but now we're going to go over, well, what if the first element is not a metal? So covalent naming, that's what we're talking about. Remember, covalent naming is non-metal plus non-metal. So I'll write that up here. Covalent naming, non-metal plus non-metal, and that's typically the story. Or it can be a metalloid plus a non-metal. That's when you do covalent naming. Ionic naming was when it was a metal plus a non-metal, or a cation plus an anion. Okay? So I think you have some blanks right on the slide? I see some people without their notes out. All right, so what we're doing is, this is a good summary slide. Basically, if they give you N2O3, you know that this is a covalent compound. How you know that is nitrogen, that's a nonmetal, oxygen, that's a nonmetal, so it's going to be covalent. It'll be covalent. Now, notice how oxygen is to the right of nitrogen. The question is, well, why is it not O3N2? Well, the element that goes to the right, that's going to be the more electronegative atom. Remember, electronegativity increases as you go from left to right. Oxygen is to the right of nitrogen. That's why it goes to the right here. That's a kind of a little wrinkle in covalent naming. Because in ionic naming, the metal was always the first one. The non-metal, or your anion, was always the one to the right. Then how you say this out loud is you use prefixes. So how you say 2 is di. Di means 2. You then say the element, nitrogen, N's nitrogen, and then you have a prefix of 3 there. 3, that's the that's the prefix for 3. And then just like with ionic naming, you gotta change the ending to "ide." So oxygen, you don't say dinitrogen trioxygen, you change it to "ide." And that's basically it. There's a little bit, a few more details for me to show you, but that's the basic idea. So as I said, it's simpler than ionic naming. There's a lot less rules and exceptions. It's just making sure you don't confuse this with ionic naming. All right, moving forward, you need to know the prefixes. Now, fortunately, you've kind of have used these prefixes in everyday life. meaning mono, that means one. I hope you maybe have seen that before. Maybe it's a little rare, but like di means two. I think that should be kind of common sense for you, right? Like you've heard that before. So here, if you're gonna fill in this blank here, I have one nitrogen. Now notice how I didn't say mono nitrogen. You do not use mono for the first element in the compound. And like for example, in this first one, there's one nitrogen, one oxygen. I put mono for the second one, but I didn't say mono nitrogen, mono oxide. It's a little bit like in algebra. You don't say 1x, you just say x. It's a little bit like that idea for the first element. Okay. All right, so then this is nitrogen, and then there's a 2 here, so you say di, so it's nitrogen dioxide. Kind of like carbon dioxide, that's CO2. Carbon, not monocarbon dioxide, it's carbon, and the dioxide, so only there's 2 oxygens. Okay? I think it's kind of neat a little bit, you know, like actually learning how things that you've heard said before, like the rules behind why it's named. All right, then looking at 3, they're telling us there's 3, the prefix for 3 is tri. Like a triangle, there's 3 points, 3 corners. I don't know. I'm not a geometry teacher. But N2O3, so dinitrogen, 2 N's, 3 oxygens, so tri, and then you say oxide. And then if you have 4 atoms, you say tetra. And so tetra, if it's if they give you dinitrogen tetraoxide, you would say N for nitrogen. Di means 2. Tetra, that means 4. Oxide is O. So it's N2O4. All right? Then going here, the prefix for 5 is penta. So the example is dinitrogen pentaoxide. 6 is hexa, so if they give you SF6, it's sulfur hexafluoride. Sometimes you'll see a space between like the prefix and the name. For the purpose of the formative, write it like this. You know, like keep the prefix and the name all as one. It's just sometimes you'll see it like that. I don't know. I don't know if it's a British thing or something, and I don't know. Just for our purposes, you know, tetra, phosphor, decoxide, just keep that, you know, have a space between the two elements there, but like keep the prefix and the name together. So finishing this off, 7 is hepta, IF7, that would be iodine. Notice how you don't say monoiodine, you don't use mono for the first element. 7, I said it's hepta, F is fluorine, so 7, hepta, and then you gotta change the ending to I. Set iodine heptafluoride. 8 is octa, that's P4O8 is the example, so tetraphosphor decoxide. Another way of saying this would be tetraphosphorus. Actually, this one wrong. This is an 8. That should be octa. That'd be octa oxide. Okay, so don't let that confuse you. Here, this one's kind of weird and maybe not as obvious. Nona, that's or I don't know if it's Nona or Nana. That's 9. So the example here they gave you is tetraphosphor. So tetraphosphorus, so P4, and then Nana sulfide. So sulfide is S, talking about sulfur, and there's 9 of them, P4S9. And then finally deca, that's 10. So giving you tetraarsenic decoxide. Is there any questions on this? I think it's a little more intuitive than the ionic naming. Yeah, and that's it, everything all filled in. Now, there are some exceptions to this because before we came up with this naming system, there are some compounds that we had been using that we had already given the name for. For example, water is H2O. What would be the name of water if we named it according to the rules I just told you? How would you say water? technically. H2O, it's not water. I mean, it is water, but like, how are you supposed to say that, Mohammed?
Dihydroxide.
It's close. Not hydroxide, dihydrogen. You would say the hydrogen, and then monoxide. There's one oxygen, so monoxide. Dihydrogen monoxide. Didn't that sound terrifying? Like, I'm gonna give you some dihydrogen monoxide. You know, it sounds like you're about to die. NH3, that's ammonia. If you were to name that properly, what would that technically be? Kurt? Yeah.
Nitrogen tri.
Nitrogen trihydride. Yeah. Trihydride. It's kind of a goofy one. But we just call it ammonia. Yeah, no, good.
For the first one, for oxygen, you put monoxide. Why didn't you put monoxide?
Oh, yeah, there's kind of a weird, like, so Noah's asking, like, why didn't I go monoxide? Because, like, the base for one is, the prefix for one is mono. I don't know. That's just a weird exception with oxygen. I guess just because it just sounds goofy to say, like, monoxide. It's just like, let's just have that O be shared between the oxygen and the mono. So that's just kind of a goofy little exception there. Okay. All right, and then the last one, and so you have to memorize these. Like, you need to know these three exceptions here. So the last one is CH4. That's methane. So methane can be like a fuel source. But how would you name that if we were to use the covalent naming rules? So C, that's carbon. Remember, don't put mono there. Carbon, 4 is tetra. And then it's hydrogen, so tetrahydride. But we just call it methane, because that's just what people have been calling it for a long time. All right. Cool. There, in your notes, I also had like acid naming in this same section. We'll talk about that either on Wednesday or we'll do it after the break. I just want to focus on this for today and have you practice a little more ionic naming. I don't know why that's there, actually. Is this in your notes? No? Okay. Yeah, I don't know why it's there. Okay, that'll do it. So you can start working on the formative.